All right, we're finishing up with our last one of our FreeFall practice questions. Number 5, we have a man standing on the edge of a 20-meter high cliff. He throws a rock vertically with an initial velocity of 10 meters per second. It's positive, so it's going to go up. We're standing here. We're 20 meters on a cliff, right? So we're standing up here. The ground's down here, and we're going to launch this thing going up this way. His initial velocity is equal to 10 meters per second. Other than that, we don't know a whole lot. It says, how high does the rock go? So we're looking for max height. We know the final velocity that's max height. Okay, so the velocity at the top is equal to 0. We know that acceleration is g, which is negative 9.8 meters per second squared. Okay, we know his y initial is equal to 20 meters. So we have to decide, are we trying to figure out how high it went from here or from the ground? It makes a difference. Okay, so let's say from above the ground. So how high does his rock go? So we're looking for a change in position. So we're looking for his y final is what? Okay, we have two velocities and we have acceleration. We don't have anything about time. So that means that we're going to look at this equation. Velocity final squared equals velocity initial squared plus 2 times g times the change in position. Okay. Now if does anybody see 0? Look, final velocity is 0, so we can cut that guy out. And now we're going to resolve for this thing. We're looking for final position. So we're going to subtract the vi squared. So negative vi squared equals 2g delta y. So now we're going to divide by the 2g. And we get that the change in position is equal to negative vi squared over 2g. We're really not looking for a total change in position because my initial position is 0. So that's where it depends on. We're looking for this height here, and we can add 20 to it, or we can change the delta y is y final minus y initial. Okay, so we can have y final minus y initial equals negative vi squared over 2g, and then we can add the initial y to this side. Right, because if we add initial y to this side, it goes away. So now my y final is equal to negative times the 10 meters per second, and all that squared. All of that over 2 times negative 9.8 meters per second squared. And then we're going to add the 20 meters that we did. So if we ignored that and just did delta y from here and found out how high we went from here, at the end we're just going to add 20 meters. So that's all we're doing. So no matter how you look at it, whether you want to put it into your equation or you just know at the end you want to add 20 to it, it all works out the same way. All right, so we're going to have a negative of 10 squared. So it's just going to be negative 100. Right? We'll do 10. Oops, I don't have answer in there. So we're going to have negative 100 on top. And we're going to, what do I have answer? We don't even know. Oh, because I keep hitting that. Negative 100 divided by 2 times negative 9.8. And we get that we went this 5.1 meters above. Right? So this first part is 5.1 meters, and then we're going to add it to that 20 meters. So what this says with my picture is when I launched, I went from here 5.1 meters up from this spot right there. And now if we want to count from the ground, so we're 5.1 meters above the band, and then we're going to add the 20. So we're going to get that it's 25.1 meters from the ground. Okay, so this is from the man right here, and this is from the ground out here. Okay, we're talking about this ground down at the bottom. Make sense? So it just depends on which one you're looking at. And they didn't really say, but we got our bases covered. How long does it take to reach its max height? So now we're looking for time. Time is my unknown. I still have all these same givens. I have the initial velocity. I have the final velocity. I have acceleration. So remember, if we have final velocity equals initial velocity plus AT. Remember, this is a G now. And we're looking for time. So we're going to solve this for time. So we're going to say velocity final minus initial velocity. We're going to subtract that, and then we're going to divide by G. That's equal to my time. So my final velocity was 0, right? We could have just crossed that out to begin with. So we just have negative 10 meters per second all over negative 9.8 meters per second squared. And it's basically going to be 1 second. Oh, sorry, get that on the screen where you can see. And so we're going to have our negative 10 divided by negative 9.8. Why do I keep getting that answer? Try it again. Negative 10 divided by negative 9.8. And I get 1.02 seconds. And that's it. There's number 5.